here's the basic AppExpress summary panel. It gives you can select any number of appliances. It gives you a listing of all of the AppExpress apps, the group, the target quality that we're trying to achieve, the current transport that users are actually being sent on, and some other stuff. But you'll notice the important part here is that the user QoE column now has a little squiggly chart box in it, a little squiggly clickable object. So this entire feature actually is just these two new little items next to the user QoE and the ping QoE. So you can click these, and when you click them, it'll pull up a modal dialog that will give you a 4-hour and a 1-day view of that application by its user quality of experience, which is the purple line, which is actually, in this example, it's kind of slammed. It's fully maxed out at 100. But you can see it dropped here just a little bit. It gives you a ping QoE, which is the best current ping score for the path that we were on at that time. And then this orange line, this is the target QoE. So basically, if the user QoE falls below this orange line, then AppExpress switches the path. It says, all right, the users are no longer experiencing, they're not achieving the target quality of experience we expected. It has a list queued up because it's been pinging constantly all of the other potential paths. So it has an idea of what the next best path is, and it puts the users onto that path. It then measures the users and just repeats the cycle over and over until we find the best path, or find a path that is above this orange line. So when you're looking at this here, it's showing you what the users are experiencing, and these diamonds are, you can mouse over them. They're an indication that the path switched, that the users fell below the target quality of experience, and that something happened at that point. You have to mouse over this little diamond. And when you mouse over the diamond, it will say old path. You can see it here, HP, SSE, INET B, primary A1. That's where we were. And users started experiencing bad quality, high latency, or lots of failed flows. And so we switched the path to the next best one, which in this case was HP SSE INET A primary A1. So we went from INET B primary A1 to INET A primary A1. And in this particular example, I am polling. This was to Atlassian.net, and I was polling to Atlassian via ping plotter, in addition to what the Edge Connect was doing from behind it. And you can see that when this switchover occurred, there was a small outage. So if one of the things that feeds into the quality experience is if you have a flow that is one-sided. So if there are TCP sins, but no SYN-ACKs, that counts as an F, or it counts as a failure, and it will greatly reduce the quality of experience score that comes out of the AppDeck subsystem. So in this case, the Edge Connect said, all right, users experiencing something bad happened, and it switched the path back to INET A. And when it did that, you can see that latency actually dropped in this case. Now, one thing I'll mention about AppExpress that sometimes people miss is it doesn't, if you're already on a path that's meeting the quality of experience, it won't switch until the quality of experience is violated. So you could be pinging other paths that have better quality scores, but we're not going to actively switch to the other paths until the one we're on has a problem of some sort. So it doesn't kind of rebalance in that way. It will stay. You can kind of see that here. Once we switched here, the latency dropped. You might say, well, why didn't it switch from this still really low latency? It's like 36 milliseconds. Why didn't it switch from this to this lower latency earlier? Well, because this was also good enough. And all about optimizing multiple primary somethings, whether it's data centers or tunnels or local breakout labels. It's about breaking the tie between two things that you already expected to be primary. So it doesn't really matter which path it lands on as long as it's functioning correctly. We brought the flow table total delay value as well as the client delay and the server delay to the flow table as columns that you can see per flow. You get this total delay column, which is shown by default, and you can unhide the client and server delay columns as well. So here where you see client 0.6, that's typically what you'll see for a wired LAN. Almost, in most cases, almost unmeasurable client or LAN side latency, and all the latency will be on the server side. This number will correspond, it's very accurate. There are a couple of exceptions. We've had some challenges with certain UDP applications radius, unfortunately. Point is, you can unhide this, you can look at it. This is giving you an instantaneous view of the latency that flow experienced. These latency measurements are taken at the start of the flow, and that is all.